Okay, welcome. In this lesson we will learn how to build a bank. Yes, a decentralized bank, not only but an unstoppable bank, and a bank that will run forever without any human intervention, nothing, and especially unstoppable. Okay, let's start. First of all, the bank will have to deal with money, so we will have to learn how to move money. So, oops. This is, you should know very well, it's remix contract. Just may I write something? Contract. Let's increase the font size. Example. Okay. We have the address public A. Okay. The address is a type in Solidity. The address has an attribute which is called balance, which tells you how much money is in that address. Okay. The address has a function which is transfer, which let you transfer X way. So I put a comment. Okay, it transfers X way. So it's not X ethers, X way. Why doesn't the comment work? Maybe it's in the other direction. Yes. So the transfer function transfers X ways from contract to address. So it's important to know that it does not transfer from the address, obviously, because the address is not yours. It transfers from the doesn't belong to the contract. It transfers from this contract here to the address A. Okay. Okay, there are other functions, but these two are this attribute balance and this function transfer are the most used ones. So let's say balance of A in way. But it's in way, so it's not in either. Okay. Another thing which may be useful is this one. Address this. This is the address of the smart contract that you're working on. Okay. Okay. I think for the address everything is said. Another thing that we have to say before is that a smart contract can receive money, but it can receive money only through payable function. So function, give me money. Okay, it's a function. Let's see. Don't care what is it. A public payable. Okay. Let me. Okay. Anybody who calls give me money can also attach. The function can do whatever you want. It's just a standard function. Anybody who calls give me money can also send either to the contract. If you call a function, a payable function, if you call a function which is not payable and you send either, the transaction fails. You still pay the gas. Okay. If you send either to a contract without calling any function, okay, usually the transaction fails unless you have a function with no name. Okay. This one. This function here. This function is fallback. Technically, this function, there can be only one function without name exist. There can only one function without name exist. It's called a fallback function, and it's used in case the contract receives money, just a transaction, so money without any function calling. Okay, if you set a fallback function, so a payable function without a name, automatically the money is accepted. Otherwise the money is not accepted. So pay attention, because to accept money, a contract need to have a payable function, usually a fallback function, because people tend to send you money without calling any specific function. Okay, I think this being said, okay, wait, because it's public. Okay, I think we have said everything. Let's see how to build our bank. Oops. This time, since I will deploy the contract a lot of time, I will not work on the Link-B network, because otherwise every time I have to make the transaction. Okay, I will work on JavaScript virtual machine, so on my own virtual machine. At the very end, I will work on the Link-B network, so we can make the test all together. Okay, so program, bank, program, contract, bank. Okay, let's see. What does a bank do? Well, the very first thing a bank does is getting money. So immediately I should set a function payable. But the money that you get must be put into the customer account. So you must know where to put the money. So we must build a data structure which will store the customer accounts and the money they have there. Let's see how we do it. Okay, mapping address int balances. Let's keep it public for the moment. Okay, let's see what is this one. This way here, balances is a type of structure, and it's like the Python dictionary. If you have not attended a course of Python before, it's like an associative array. It means that it uses addresses as keys and can contain int. So it works more or less like this. Balances of here you specify the address equal. Okay, and at this point we have the balance of an address equal to that thing here. So it's very useful in cases like this, whenever you don't know a priori what are you going to have, how many addresses are you going to have, and you're going to use them a lot. So we build a structure like this. It's sort of it's exactly the same as the dictionary in Python. Okay, this will keep our addresses. I don't think we actually need anything else. Maybe just the owner of the bank. Well, in theory, it's a bank without owner. Okay, but for the moment, no owner. So let's set no owner. Okay, so the bank must get money. So function. People will send the money without calling any function. For technical reasons, starting from Solidity 0.5, public, it's better to call it external in this case. So don't worry, write external, it means public. For use, let me know, okay. Okay, so what do we do whenever we get money? Whenever we get money, we have to update the balances of customer, the customer who is sending the money, so message sender plus equal. This is exactly as in Python. It means equal the balance that was before plus, if you prefer, MSG. Okay. So plus equal is the same, plus message value. Message value is a global variable, so a variable which always exists, which tells you how many way, not either, how many way have been sent with this transaction. So we take how many way have been sent with this transaction, and we send them to the sender, to the balance of the, we add them to the balance of the sender. That's it. So for the moment, the only thing our bank can do is get money. Let's see whether it works, whether it compiles and work. It's just an attempt, so it may make mistake. One warning. What's a warning? Too much gas. Who cares? I'm not paying to guess. So now let's deploy onto Java virtual machine, otherwise we stay here forever. You have here some accounts with 100 Ether. So now we deploy it on the JavaScript virtual machine. Deploy. Okay, it's here. Okay, so now I send some Ether. I have the fallback function. Pay attention because you don't have to write what you send here, because the fallback function doesn't need any argument. You have to write what you send here. So let's send some way, because I'm stingy. So 200 way from this account 0 by CA. So fallback. Okay. Let's see whether it has been sent correctly. Have here. This doesn't really go on any blockchain. It goes only on your computer blockchain. So the only way to see it's 200 way send it here. You can see that the account balance has dropped. Okay, let's send again from the same account. This time 20,000 way. Okay, pull back. Okay, let's send money from another account, from 147. From 147 I will send a huge amount of money, 3 Ether. Fallback. Okay, let's see. Can you see how many way did I send here? Okay, this is 3 Ethers, a lot of way. Okay, now let's check the balances. So the balance of the first account. Copy. V. Balance. Can you see? 2020. Okay, fine. Let's see the balance of the second account. Copy. Balances. Okay, fine. So we have the function which can transfer money. Okay, if you want, you can call this function transfer or deposit. But if we call it deposit, then if a person sends money just randomly, just to be precise, we build also a function deposit. Okay, payable, public. Okay, it is still payable. Okay, so deposit function will deposit what you put as value. Okay, and you may also specify the address in this case. Address. You must specify address payable. No. Address is enough. X. Okay. Pay attention that with deposit, you are not putting the money in your own address, but you're putting the money in somebody else's address. Okay. On the bank. So let's deploy it. Okay, let's remove the old one. Oops, deposit has disappeared. It's public. Let's remove everything. Deploy. And deposit, where is it? So I have to compile it. Forgotten. Why every time I have to select a compiler version? Okay, done. Okay, deploy. Delete the old one. Okay, fallback deposit balances. Okay, let's send from this account 1 Ether, about 0.5 Ether. Okay, let's send from this account, or better, copy. I specify the address of the last account and I send from this one. So from this account I send 3 Ether to an account which belongs to the last one. So deposit. Okay. Let's see. the balance of the last one. The balance of the second should be 0 because the only deposit that has been made was on another person name, in fact 0. And the balance of the first one should be half ether. Okay. So we have a deposit if you want to deposit on behalf of somebody else. This one plain if you want to deposit for yourself. Okay. And now you will like also to withdraw money. Okay. Please note that every time I deploy, it's a new bank. Not so. Now function withdraw. Okay. So you withdraw money. Okay, you can withdraw money only from your own address, so we don't need to specify. You need to specify only how much do you withdraw. So unsigned int, uint means unsigned int. So it's an integer, positive or 0, so cannot be negative. Uint, say q means quantity. Public. Okay. Yes, think it's well enough. Okay. What does it do? Well, the very first thing it should do, the basic thing it must do is the following: balances of msg.sender. Sorry. First thing, let's do the following. First we pay, so msg.sender. This is the address of the sender. Okay, let's put it in parentheses. We transfer q money. Okay, so we transfer an amount of money q to the address of the sender, but maybe it can be a good idea before doing it to check whether the sender has enough money on the bank. Okay, so maybe it's a better idea if we check here. If balances of msg.send larger or equal to q, and here I need the colored braces. Okay. So the function transfers money only if the balance of the sender is larger or equal to q. Otherwise, goodbye, doesn't do anything. Okay. And after having transferred the money, we need to update the balances of msg.sender minus equal q. So we deduct q from that balance. Okay. Let's check. Yes. Okay. We need to recompile. So I clear up everything. Compile. Done. 3 warnings this time. Always the same. Guess requirement, fallback function, potential violation of check effect pattern. Yeah, okay, don't worry, I will explain later. Now let's deploy it. Deploy the first one. Deployed. Okay. Now the first account will deposit 100 way, not either. Okay, fallback. The second account will deposit 200 way. Fallback. Okay. So now there should be 100 way into first account, 200 way into second account. Let's see. The third account now will try to withdraw 50 way. Everything is in way, eh? Let's see how it does exactly 100 either. Let's see whether it gets the 50 way. Nothing happens. Okay, it has slightly less. We can see because there is the mining fee. So wait, let's deposit much more. So the first account will deposit 2 ether. Okay, fallback. Okay. Now the first account has 2 Ether, the second has whatever. Okay, let's see the last account. The last account will try to withdraw money. We'll try to withdraw a lot of money. Let's see. Okay. Let's see. Did we get something? No. It has even less money than before. Okay. Let's see what happens. The first account has a balance which is, let's check. The balance of the first account is this one. Let's try to withdraw more. So the first balance will try to withdraw more. So 3 Ether, for example, instead of 2. I zoom. Okay. The function doesn't say anything, simply doesn't give you anything. Okay, let's see if it tries to withdraw exactly 1 Ether and a half. Let's see. Okay. So can you see? Now it was 97, now it's 98.99. Now I think it still has half Ether. Let's withdraw also that half Ether. So currently it has 98.99. Withdraw that half Ether. The balance drops to 0 and it has 99.49. Okay, so the withdraw function works. However, here I must make a remark, a very, very important remark. There is a big problem here. Look what are you doing. You are first sending the money and then subtracting, so adjusting the balance. If for any reason the execution is stopped between line 16 and line 17, you have sent the money but not updated the balance. There has been in the Ethereum history a very, very famous case in which a hacker managed somehow to stop the execution, or at least to slow down the execution, and managed to continuously withdraw money before the instruction to update the balance is executed. This is never a good idea, so it's much, much better if you first update the balance and then send the money. So first update the balance and then send the money. Okay, so in this way, if the hacker stops something, he will lose the money and goodbye. Okay, if you want to do something even better, first set the balance temporarily here, then transfer the money, check whether the money has arrived, and then in case so, but doing this is at least safer for your contract. Okay, so we have a function which deposits money, a function which withdraws money. Let's see a function which transfers money from one account to another one. Function transfer. Okay, so address. Now let's start how much. Quantity. Address. Let's see. Receiver. It's public, and that's it. It's similar to this one, so I copy and paste because I'm lazy. So if the balance is enough, so this is quantity. Okay, if the balance first I remove money from the sender, and now I don't need actually to transfer anything really, because it's just a transfer inside the bank. Okay, plus equal quantity. Okay, also here first I remove the money and then I put it. Okay, important thing. Okay, so I have everything. Yes, I need to recompile it. Compiles without error. Deploy. Okay. Oh, now it starts to be difficult to track how many ethers they have. Let's deposit the first account, as usual, deposit 5 ether. Okay, deposit means deposit at its name. Okay, the balance of the first account is 5 ether. And now the first account transfers Where is it? Oops, I deposit on the wrong contract. Oops. Let's redeploy it. Deploy, okay. Now, the first account deposit 5 Ether. Okay, the balance of the first account. Copy. Contains 5 Ether. Okay, now let's transfer this quantity here. Not all, let's transfer only 1 Ether. 1 Ether. To this one. This address here. So 1 Ether, comma, this address here. Transfer. Okay, done. Can you see? Now do you understand the reason why I'm using JavaScript, the virtual machine, and not the real blockchain? Otherwise, I would have stayed here every time, make the transaction, pay the fee. Okay, now let's see the balance. What's the problem? Still 5 Ethereum. And the balance of this one? Okay, because yeah, I understand why that didn't work. Because I tried to move money from the wrong account. I have to move money from this account. Okay, this account now transfers the money. Okay. Oh, now 1 Ethereum has arrived in that one, and and let's see how much Ethereum have been left on the first one. Okay, 4 Ethereum. Okay, let's finalize a little bit our bank. Now our bank works perfectly. We have an unstoppable bank. You can deploy it now on the real blockchain and try with different accounts. It will work exactly the same way. Now we have a bank which can't be stopped. Nobody can do anything about that bank. The bank will work automatically forever, as soon as we deploy it on the real blockchain, at least until Ethereum exists. It's very important. It can't be censored. Your account is there. It's only yours, and only you can use it. So it will work forever. We can fix some little things. For example, why are the balances public? Let's keep them private. Okay? But if the balance is private, maybe the owner of the balance would like to get to know how much money does he have. So we have function tell balance. Okay. It's a view function, public, everybody can use it. The function checks if the function tells your balance. That's it. So very simple. So returns you int return balances of your balance, so msg dot sender. Okay, tells you how much money do you have. Okay, so compile. Error. What's the problem here? Undeclared. So int balances are msg. Compile. Okay. Run. Remove the old one. Deploy. Okay. So now you see you cannot get the balance anymore. You can only know your balance. So this person sends 5 Ether. Fallback. Okay. Tell balance. Okay, but if another person asks for a balance, you get to know only his balance, which will be 0. Okay, so it's not possible to know the other people's balance. Perfect. So now we have also a bank which respects the famous bank secret. Well, everything works, I think. Seems to work, seems to work, seems to work. Okay, the only further modification that I'm going to make is this one. Let's comment out this. So if you want to comment out an entire part, it's easy because you can just starting with this one and ending with this one, you comment out an entire part. Okay, very useful. Usually it's done like this. Okay, use this one if you want to comment only. It's equivalent. This one is the equivalent of this symbol in Python. Okay, well, this one lets you comment out the entire part. Here, I would rather use a slightly different way of writing it. So, require okay. So instead of the if, you can use the require. The require works more or less as the if, but does not admit any else. The require checks whether this one is true. If it is true, it goes on. If it is false, first of all, it stops the execution immediately, okay, and reverts any change which has been made. Okay, stop also the guess usage. So usually it's preferable whenever possible to use the require. If you need the if and the else, okay, but if it is something, if the function must work only under certain condition, and this is the case, the function must work only if you have enough money, require it's usually preferable instead of if. Okay. So let's see, I will use it also in the other one here. Then you don't need even to indent, and you don't need this one anymore. Okay, let's see whether everything works. Compile. Undeclare require. Undeclare. Discover why I didn't compile. I use quantity here instead of q. Okay, now it compiles. So require works fine. Now just to check, I deploy it again. Okay. Now this account 147 sends to Ether. Fallback. Okay, let's check its balance. Okay, to Ether tries to withdraw 3 Ether. So Ctrl C, Ctrl V, 3. Okay. Check again the balance. Same thing because the withdraw didn't work. If you try to withdraw exactly to Ether, check again the balance, 0. Okay. Okay, so require. It's if you have, especially if you have to deal with money, it's usually better than if, because it stops immediately the execution. Obviously, you use it only when the function is not meant to work if this condition is false. In this case, if the condition is false, the function is not meant to work at all. So you put require, the function immediately stops execution, returns the gas consumption is stopped, and anything which has been changed is reverted back also. Okay, so let's see now how can you interact with the contact of another person. In order to interact with the contact of another person, you need two things. You need the contact address, but that is not enough because you don't know which function does that contact have. So in order to interact with the contact of another person, unless the other person gives you the full code, but this is rare, you need the contact ABI, application binary interface. Okay, let's see how to get it. For example, suppose this is user 1, okay, using the white screen, I'm using Chrome browser. Okay, I have here the usual bank contract. Okay, I compile it. I deploy it on Linkby, obviously. Okay, I deploy it from this address 0x52, so it will be, it's my account 1. Deploy. Okay, MetaMask opens up. Firm. Okay, contract is almost deployed. Okay, deployed. Very well. Now I have all the usual things. I will deposit some money, for example, 150 way. Okay, directly make a transaction. MetaMask. Okay. It's funny because I spend more in commission rather than in money. Okay, let's see. Okay, done. My balance 150. Okay. Now I want other users to access my bank, deposit and make things. So I have to give them the address of the bank, which is this one, and the ABI. You can get the ABI from here on the compiler. Okay. Here you just click and you copy the ABI. If you're curious about how does the ABI looks like, compilation detail, here's the ABI. If you look, it's basically a list of all the functions that you have in your contract: withdraw, transfer, etc., receive, etc., etc. Okay, so I have here another user. Let me get it. It's on Firefox. Okay, this is another user. This user doesn't know anything, doesn't have the code. Okay, will receive only the address and the ABI. So let's give him the ABI. So I copy the ABI, go to the other user. Okay, new bank.abi. Okay, I paste it here. Oops, I can't paste it, right? Go here again. I copied it. Okay, copied. Why I can't paste? Ctrl V. Okay. Okay, it's the ABI. Okay, now in order to I go to deploy and run, I can't, however, interact until I have an address. So I have also to get the address. Oh, I copied the address. And now I tell to Remix that I want to interact with this program, with which I don't have the code but I have the ABI, at this address here. So I click address. Say, do you really want to interact with this contact using the current ABI definition? Yes. Okay. And here you can see it does correctly recognize. Okay, I am interacting with my account too. So if I tell my balance, it will be 0. Okay. Now I deposit some money also here. Deposit 5,000 way. No, and not deposit. I have to deposit in this way. 5,000 transact. So I deposit 5,000 way on my account. That's the way. MetaMask is asking me the permission. Okay, pending. Is it done? You can see in the meantime, this is my transaction. Come on. It's really annoying when, okay, I will see the transaction later on. Tell my balance, 5,000. Transaction, does it appear? No. Okay, now I will transfer money from account 2 to account 1 inside the bank to show you that I'm working on the same bank. Okay, so I take the address of account 1, which is here. So 052F. Okay, I go here. So I transfer to this address here. It's the 0x52, quantity 2000. Okay. So from my bank account, which currently is 5,000, I transfer money to the other bank. You will see that the other one will be able to see it. Transact. Okay. Oops, I'm actually not transferring but depositing. No, I'm transferring.
Yes, I'm transferring. Okay, let's see. Okay, done. Now I check my balance, which should be less, 3,000. I go on the other user and check his balance, 2,150. So they are interacting on the same bank. Okay. Now, by the way, let's see whether finally, let's see all the contract activity. You can see the contract has been deployed by this user here, 052. I zoom. 052. Then the other user made a deposit, and the other user made a transfer. So both users interacted with the same contract. So this is the way to interact with them. Pretty easy. You just need to send the address and the ABI. The ABI must be loaded as if it were a real file, a standard file. I mean here, okay, and the address here at address. Make sure, not like me, that you are on injected Web3 and with MetaMask open. Then you click at address, and from that moment on, you are able to interact with the contract exactly as the other one, which is the original contract writer, let's say. It's not the owner, because the owner is the ones which is written inside the smart contract to be the owner. It's, let's say, the person who wrote the contract. So they can interact exactly in the same way.